Hi guys, so today we'll be talking about Pythagorean theorem. This is a cool alternative rather than us taking 20 minutes or so on notes. Now you guys get to do it online. So go ahead and make your cornell line as usual, entitled Pythagorean theorem. We're then going to start with our vocabulary. And like for you, there are only 3 terms that we'll be talking about today. Okay, our first term will be Pythagorean theorem. What is it? When do I use it? This is a big word, Miss Bundy. What are you doing to me? I know. By the end of this, it will be your best friend. Okay, so the Pythagorean theorem it's a formula. Okay, the Pythagorean theorem is a squared plus b squared equals c squared. Okay, the squared simply being an exponent. It's used for right triangles only. Did you hear me? Right triangles only. Right triangles only, not acute, not obtuse. It must be a right triangle. Okay, guys, so I wanted to clarify that the equation for Pythagorean theorem is a squared plus b squared equals c squared. I want to clarify, make sure that we have that. The formula is the sum, and think about what the word sum means. Sums mean the answer to an addition problem. The sum of squares being those twos, those little exponents up there. Also the shape of squares, and we'll see how that comes into play later on. So it's the sum of squares of lengths, of legs, which will be equal to the length of the, you ready for it? Hypotenuse. And we've discussed this word in class once or twice before, and you guys panicked, but here it is, guys, hypotenuse. Okay, so let's say we have a right triangle. A right triangle just simply means there's a right angle. Okay, I know you guys love my drawing so much, so there you go, right angle, therefore this is a right triangle. This would be considered a leg, and this is a leg. So we all agree that there's 3 sides of a triangle. 1, 2, 3. So I have a leg, and across from the right angle will be what we know as the hypotenuse. The hypotenuse should always be the longest side of the triangle. A leg will be considered A. The other leg is B. The hypotenuse will always be C. The hypotenuse will always be C. Your legs are A and B. Your hypotenuse will always be what? Very good, C. All right, that was it for our first vocabulary term. Next term, we've already discussed in the previous vocabulary term, legs. So what are legs? Let's just put it on paper to clarify. It's 2 sides, 1, 2, right? 2 sides that form. I'm going to ask you, what did these 2 legs form? The legs, what did they form? They formed a right angle. So this leg connected to this leg should form a right angle, which is also known as a 90-degree angle. Okay, so legs are 2 sides that form a right angle. Okay, and last but not least is our favorite word, hypotenuse. The hypotenuse, by definition, is the side. And anytime it says side, it's talking about where it's located on the right triangle. It's the side opposite of the right angle. Let me slide it over so you guys can see. The side opposite of the right angle. Again, also known as the longest side. Let's draw an image. Now, I'm going to ask you, where is the hypotenuse? Find the right angle. There it is. Across from it is your hypotenuse, your letter C, and your legs, A and B. Now, you can call this A, or you can call it B. But the one that must always remain and be the same is C. C has to be the hypotenuse. So you can call that A, call this B. It doesn't matter about the legs, but what matters is C. C cannot be located here nor there. The longest side opposite the right angle is your hypotenuse. All right, it's time to go into solving for the hypotenuse. So now we're going to do some practice as usual. How do we solve for the hypotenuse? All right, excuse my nails, guys. Number one. Here we go. So let's say you're given a picture of a triangle that looks something like this, right? It has to be a right triangle. So go ahead and draw it. All right, let's say they give you 5 on this side and 8 on this side. And they give you a variable. I'm going to use C so that we can get acquainted with knowing that C is the hypotenuse. How did I know that was the hypotenuse? Again, it's across from the right angle, okay? All right, so in order to solve, I use my formula. Your formula for the Pythagorean theorem. Pythagorean theorem is only used with the right triangle. Is that a right triangle? Yes. So here we go. A squared plus B squared equals C squared. Just simply start with your formula. All right, guys, remember we said that C is always the hypotenuse. Do you have C? No, you do not, but you do have legs, okay? So here's a leg. A leg is A or B. So I'm going to use this for A. I'm going to plug this in for A. 5, and the squared stays. Plus, that's my B, 8, and again, the squared stays. Should equal C squared. All right, so now I have one variable left and an equal sign. We know we can use what on our calculator to solve for a missing variable? That's right, InSolve, okay? Now, we need to practice and do this by hand first, but if you want to use InSolve, that's always a tool you're going to use, but I expect to see your work until further notice. So 5 squared, which is 5 times 5, is 25, plus 8 squared, which is 8 times 8, gives us 64 equals C squared. Okay. Now, I can do this. 25 plus 64. Well, 5 plus 4 is 9. 6 plus 2 is 8 equals C squared. Are we done? That's my question to you. Are we done? Well, is C alone? Is C by itself? No, it is not. It has a square attached to it. How do I undo a square? What's the opposite of a square? The opposite of a square is square root. So from this point, we now have C equals the square root of 89. And at this point is where you would pick up your calculator and you would type that in, the square root of 89, and you should get something close to 9.4. Now, when we do this, most of the time we're going to round to the nearest 10th place. So go ahead, check your calculations, make sure that that's what you got. If it's wrong, or if you think next Monday is wrong, we'll have a talk about it later. Square root of 89 is 9.4. All right, second problem. Go ahead and draw this right triangle. I'm going to ask you to go ahead and mark where you think the right angle would be located. Let me give you a second. Mark it. Okay. If you marked it here, you're correct. If not, go ahead and put it there now. Let's say that this side is 3 and this side is 4. Again, across from my right angle is my C, my hypotenuse. Now notice these two triangles do not look the exact same. They can give you a triangle however they want on STAR test, so be prepared and know that the right angle is the key to where the location of the hypotenuse is, okay? All right, here we go. I use my formula. A squared plus B squared equals C squared. I'm going to go ahead and box the previous answer so that we'll keep these two separate. All right. What am I going to plug in for? I'm plugging in for a leg and a leg because I'm missing my hypotenuse. So leg 1, I'm going to call, say it's 3, right? Keep my squared plus 4 squared should equal C squared because I do not know C. They did not give it to me. That's what we are solving for, again, the hypotenuse. What is 3 squared? It's 9. 3 times 3, correct? What is 4 squared? 4 times 4 is 16. And again, I'm left with C squared. At this point, we now can add 9 plus 16 is 25. Are we finished? The answer is no. C is not by itself. I need to do the inverse. What is the inverse of square? Square root. I'm left with C is the square root of 25. What is the square root of 25? You should not need a calculator for this one. We know that the square root of 25 is 5. Great job. All right, guys, you should be out of a room by now. So go ahead, turn over on the back. Use your ruler or your edge of your paper. Go ahead and make your Cornell line. And we're now going to talk about, okay, we've solved for a hypotenuse, but how would we solve for a leg? Okay, so how to solve for a leg will be the next few practice problems. Okay, again, let's start with the triangle. Here we go. Go ahead and identify where your right angle would be located. Good. If you put it there. Now let's say that they give you this side is 16, this side is 25. Solve for that side. So what am I missing? That's always the key. I first identify what is missing. Is it a leg or a hypotenuse? It's always going to be one of the two. Either I'm solving for a leg or I'm solving for the hypotenuse. You still always start with your formula. Okay, what is our formula? A squared plus B squared equals C squared. From that point, we then just plug in values. So what did they give you? They gave me a leg. So would I plug it in for A or B? The answer is it does not matter. I'm just going to choose A. So let's say 16 squared plus, I'm missing a leg, therefore the variable should stay in place on this case. Equals, did they give you C, which is the hypotenuse? Did they give you the hypotenuse? Let me find my right angle. Across from it should be my hypotenuse. Did they give me a value for that side? Yes, they did. 25 squared. And again, remember, the square, those exponents should remain. All right, so 16 squared. What is 16 squared? Which is 16 times 16. You should get 256. Plus, I bring down my variable, 25 squared. 25 times 25 is 625. All day long. That doesn't change. What do I do from this point? I have a variable. I have an equal sign. Again, yes, you can use insolve. However, as I stated before, I want to see your work, so insolve is not going to cut it right now for us. So let's go ahead and solve. If you have one variable, the goal is to get the variable by itself, right? So if I want b alone, I first need to move the unattached number. How do I move a 256? Ask yourself, is it positive or is it negative? I don't see a sign out here stating that it's negative, so it must be positive. Remember, to move it, I must do the inverse, aka the opposite. What is the opposite of a positive 256? Negative 256, also known as minus 256. I need to balance the equation. What I do to one side, I must do to the other. So 625 minus 256. All right, when you subtract those two, you should get 369. Okay, 369 should equal, and then I bring down my b squared. Okay, my question to you is, are you finished yet? Your answer should be no. Why not? B is not by itself. It has not been fully isolated. I need to get rid of a square. How do I get rid of the square? Again, I do the inverse. What is the inverse of square? Square root. So b equals whatever the square root of 369 is. Go ahead and do your calculation. If you round to the nearest tenth, you should get something close to 19.2. Great job, guys. Okay, we're almost done. The last thing that you'll need to know and be able to do with the Pythagorean theorem is you need to be able to tell how to tell if it is a right triangle. So what's going to happen is you're going to be given 3 different side lengths. Okay, so here's an example. They may give you a picture. And if they give you a picture, they may not tell you, oh, this is a right angle. They want you to tell them if it's a right triangle. They're going to give you side lengths. And you can't always just look at an image and tell. We will need to be able to know for a fact. Knowing for a fact always comes down to calculation. So what you'll want to do is use the Pythagorean theorem. Now here in this image, did they give you a right angle? No, they did not. Okay, but we know that the hypotenuse should always be the longest side. So if this is a right angle, 10 should be C. And again, it does not matter what you put in for A and B. All we need to know is that the smaller two sides are legs. C squared, not C squared, 6 squared. 6 times 6 is 36, plus 8 squared, 8 times 8, 64, equals, I need to solve. What is 10 squared? 10 times 10 is 100. Now, this is a right angle if this side equals this side. Let's see. 36 plus 64. 6 plus 4 is 10. I'm going to carry my 1. 6, 7, 8, 9, 10. Do both sides equal? Check. Then that means that, yes, this is a right triangle. You may see something. Here's another example. We'll call this example 1. Example 2, you may see something like this. 10, 12, 18. Something like this, they want to know if a triangle has these side lengths, is it a right triangle? The only way to tell is to perform or use the Pythagorean theorem to see if this side equals that side. So again, your largest number